right, this Unit 5 free response material is just Unit 5 in general, paying attention to the sampling distributions. And again, how important it is to pay attention to population notation and understanding of the parent population information versus the sampling distribution with all the samples in it. Okay? All right, so this first problem gives us some information about a population D and about the lengths of the turtles in that population and a population E. Okay, so just in general, what we have been told, because I like to just keep this, so the population proportion is stated that 30% of them have that turtle shell length greater than 2 feet, and that E's population percent is 20%. So we are told true P for both population D and population E. But they then take a sample, and that sample that they get is our P hat. Okay, so our P hat for D population of those turtles was that 15 out of 40. Okay, so if we had that 15 out of 40, then that's how we get our, whatever that number is, of 0.375. Okay, and then we have that P hat for the E's, and that was the then 11 out of 60. And so then that's why they had that number 0.183. All right, so keeping straight what we are told the whole population has versus what our sample hat results are. Okay. So this question first asks about the difference in those P hats. So see, it's asking about the difference in the sample results. So that's why we use the 0.375 and the 0.183. So the sample difference, okay, so keep in mind that the sample difference is that 0.192. All right. Now, scoring, you calculated the response correctly and you showed your work. Okay, pretty straightforward. Showing your work, showing how you got these numbers. Okay. All right, next. This one then says, okay, so what is the mean and the standard deviation? So they say, what's the mean and the standard deviation for the sampling distribution for that difference of those sample proportions? So let's think about what that's saying. That is saying, it is talking about a sampling distribution, and this, all of the sample results, so this little number here and this little number here and this proportion number here and all of these little these results, okay, all of these results are samples, and every single one of these dots is coming from 40 turtles from population D and 60 turtles from population E, and we subtract the population D, the sample for D minus the sample for E, and then we place that data right there. Okay, so we're getting pieces of every single one of these yellow dots represents a sample of 40 from D, 60 from E, and subtracting them. This is the sampling distribution of those differences in sample proportions. Sampling distribution of all of these P hat differences. Okay. So from the formula chart, so let me show you this. Here is the back of the formula chart, the second page. For two populations right here, I'm going to zoom in on this area. Here is the mean, and here is the standard deviation, okay? And so that's what I have right here. I just looked at it closer. So I want to say where all of those sample differences are centered is going to be where the population differences should be centered. So most of our differences should be that population for D minus that population proportion for E. And that's what I have down here. Remember, the best it can be is if you use true P. So I have the population proportion for D minus the population proportion for E, 0.3 minus 0.2. I'm using these numbers here, okay? All right, so that means all of these samples should be centered around a difference of 0.1. 0.1, a difference of 0.1. Now, the one we got was the difference that we had in our sample was a difference of 0.192. Okay, so a little bit larger. So our sample may be this one right here, where the difference in the sample results we got were that one that was 0.192. Okay, but most of the samples should center with a difference of 0.1. Well, with what variability? Okay, here is this formula for the standard deviation, and just fill in the numbers there. You got your P1 and 1 minus P1. Now, what P1 and 1 minus P1, what P1 are you using? Population. The best it can be is if you use true P. So that's what we're doing. So I'm using these population P1 and 1 minus P1, population P2 and 1 minus P2 for the D and the E. And then, of course, those are their sample size for the D population and sample size for the E population. All right, so then that means there is where our differences are centered and with this standard deviation. Okay, so the question then now is, let's see, the question then, okay, well, to get credit on that, by the way, you show the correct mean and the correct standard deviation with the supporting work. Pretty straightforward. Partially correct if you only get one of those correct. Okay? All right. So here, now it says, hey, do we have the right to say that we have an approximately normal distribution? So can we say that that sampling distribution is approximately normal? Well, that just means we need to check those conditions and assumptions. So that's our random, independent, and large enough. So we do have that we were told we had randomly selected 40 turtles from population D and 60 from population E. Independent, N is less than 10% of all the turtles from population D, and 60 is less than 10% of all the turtles from population E. And because we have these two groups, these two samples and populations of turtles are independent of each other. No overlap, no double counting. Large enough, that is that you have at least 10 successes and at least 10 failures. So here's my population D information. 40 is N times P. True P, population P, is 12, greater than or equal to 10. The best it can be is if you use true P. Okay, using true P there. If you don't have that, that's when you would use that P hat. Okay, but we have our true P for population D and population E. And all of those are met, so therefore we have approximately normal model. They required that you check these items, that you checked the large enough for, they just require that you checked the large enough, okay? But they very easily could have checked, actually, so for that normality, but anyway, we need to just be consistent with our random, independent, large enough, okay? All right, and finally they said, hey, you got that sample, you got the sample results of 0.192 here. How unusual was that? What's the probability that you would have gotten those results or something greater than a difference between those two populations bigger than 0.192? So that just meant this was used from part A. This is part A right here, okay? And then, of course, this we found in part B, that population mean here, and this that sampling distribution mean and standard deviation, okay? So we did our z-score formula. We got 1.03, and then we norm CDF'd that, so we got 0.15. So if we take a look back at that picture I had drawn, see, here was where our sample was of a difference of 0.192. And so therefore that we found that this area above it is 15%. Okay. All right. So it's essentially correct if they calculate the correct probability and show the supporting work. Now let's take a look at what's going on here. We needed to, let's see, the response in part D can be scored as E. Okay, let's see. Okay, so this is saying you can still get full credit for part D even if you used your wrong numbers from parts A and B, as long as those numbers from A and B were reasonable. Okay, so like you have to have a positive standard deviation. That standard deviation is an average distance from the mean, so you can't have a negative average distance from the mean. But anyway, so if you had reasonable answers for A and B, and you use those properly in part D, you get full credit in part D. Okay, so that's what that's saying. Alrighty then. So there is that conclusion of that. So I think I'm going to actually just stop because that's probably long enough in it. I'm just going to go ahead and break this up into 2 different videos. So there is that one video for that free response.